This tutorial starts with a song, but it's only a few seconds long.
Computer animation. Computer animation. Computer animation.
Let's get started with animation. Attenuation is a term widely used in computer graphics. It applies to force fields and to lights, and it's an important parameter which we'll focus on today. In Wikipedia you find attenuation as in physics attenuation, or in some contexts extinction, is a gradual loss of flux intensity through a medium. Very well, I just entered a new sentence down here into that article, and that sentence is under applications. In computer graphics, attenuation defines the local or global influence of light sources and force fields. This is a particle system. Nothing about attenuation at this time now. When the particles shoot up, they die after more or less 1 second. That's how I define them. They start as white particles and they end at very red particles, and they evaporate from that bluish surface. Now we can go to FX, select the particles, which shows us this box basically, and then go to fields and solvers and introduce, for example, a radial field. What we do now applies to all fields here, the turbulence field as well as the gravity, I guess. Let's have a look actually. Gravity. Yeah, we have attenuation right here as well. And the attenuation for a gravity field is by default set to 0. And that means that the influence of that field is the same all over the whole place. Whereas when we go to fields and solvers and to radial and check the option box, we set a default setting of attenuation to 1, which means the influence of that radial field is local. It's not all over the place. If it's set to 0, it's all over the scene. So let's apply this now, and we have a radial field which works sort of locally. It has that influence on the particles, which spreads the particles out from the center, and the effect is stronger in the very center than further away. And we can change this by setting the attenuation to 0 and check out the simulation with that value. Now the influence of the radial field is the same all over the whole scene. And if we choose a value of 3, for example, the influence is much more local. You see the particles up here spread to the top more or less undisturbed, whereas the ones in the middle, they are pushed away from the center. And of course we can move the field and see how that influence changes when we position the field at a different place. And there's a nice way to do this interactively. You need this icon here. And this icon is under FX here. Go to the beginning of the simulation, set in a value of a high value here, 1000, 5000, whatever, so you have a long playback of the simulation and you can play around with it quite a bit. And now we click here, and then the simulation starts, and we can interactively move our field locator to different places in the scene. For example, to the back of that plane. And then we have that local influence here. If we reduce the attenuation now to 0, the whole scene is influenced by the field. And with the attenuation of 1, we have something in the middle, like in between. When we raise this, the influence gets less. because the particles are already dead, or at least most of them, when they reach the influence field or realm of the force field. So that's that important parameter of attenuation. Keep it in mind, it's all over the place. Now let's have a look at the lights. For the light experiment, I wanted to have a complex sort of geometry, and I looked for a free 3D model on the internet, and I found TurboSquid, which is one of the suppliers with for models and geometry and FBX files and motion capture as well. I'm not affiliated with them in any way. I just found this, and it's free, and this was made by LBDN, and I imported that into Maya. I think it was an FBX file. Yeah, FBX. So it's here in the scene. I created a simple plane as a base, and an arc here, which you see here in green now, which makes a point light, which sits actually right here all over the house. This is the movement the point light makes. And when I go to a shaded view, which is here, I see the influence of that light. The point light was one of the most important lights in the early versions of Maya, long before Mental Ray and Arnold came in with their own light sources. And it's a little bit legacy now and outdated. I think I haven't used it in years now. But it had a parameter called attenuation in the old days. It doesn't have that now. It has the decay rate, which is basically the same. You can set it from cubic to quadratic to linear and to no decay. The realistic way to do it is the quadratic way, because the light influence diminishes by a quadratic function. Anyway, this I show you 4 renderings with all these settings here. This is the one with no decay. This is the one with the linear decay. Here we have the realistic decay, and for that purpose I had to pump up the intensity of the light quite dramatically, and even further to actually 10,000 units for the cubic version decay rate. So that's the attenuation for that old spotlight. So this is a scene with 2 objects, a cone and a sphere, and a spotlight right here. Let's focus on the spotlight just so you see where it looks at. By the way, if you want to look through that light, it's a very handy function which has been in Maya since version 1, very elegant. You either middle mouse drag this icon here from the outliner into that field, into the viewer here, or you go to using the hotbox with the press spacebar and go to panels and look through selected. So you can basically look through any selected object, like through a sphere, which does make sense, but light makes total sense. And here you can reposition the light so it doesn't touch the cone, for example, or it does touch the cone, or it's very far away or very close, or at the top of the cone, or whatever. So like this, and when we go back, we press and hold the space bar again and go to panels and perspective. That's our camera. So that's what we see. We go to Arnold and to render the scene, and that's what we see. It's a very harsh light which diminishes over space. It has a little bit that's because of the reflection of that very, very bright cone here to the back, but basically the whole light evaporates to the front, and it's much less here, and it's getting really dark a little bit further away. Let's actually invoke under renderer Arnold renderer. So we see the rendering in the viewport. These are the spotlight attributes here, the general attributes. they set the decay rate to no decay because we're using it in combination with Arnold. Arnold is the default renderer now, and Arnold doesn't care about this. The decay is not important. So if we choose linear, it doesn't change anything there, quadratic or whatever. If you use Maya for rendering, these are crucial values here. But let's go down to the Arnold section, which come with every light, and open it, the Arnold section. Here is the exposure, which I set to 20, because sometimes the lights need to be really strong. This is 10. You barely see anything. But 15, for example, starts to make sense now. And maybe 18, even more like this. Let's leave it at 18. Further down, you have, where is it? Light filters. Open that section. Empty. And here you can add a filter. And you guess what's coming up now. This pull down menu shows AI light decay. Let's choose that. And in order to get to it, you need to double click it. And this is the AI light decay node now. And here you have attenuation. You have a near attenuation. I just show you the far attenuation. Let's switch this on. Everything goes dark because the far start is set to 0 and the far end of this light influence is set to 0 as well. So let's raise this just a little bit. And now you see the cone appear, but not the sphere, because we're defining the range of that light now. So you can see attenuation is all over the place. And since I have lots of subscribers and visitors from China, please go to Wikipedia, type in attenuation, and then translate this article or create your own one about attenuation so that we have a Chinese version here, because the Chinese is missing. We have a Japanese here. That's Hebrew, and this is Hindi. We have a Persian version, Arabic here, and several other languages, but we need a Chinese one. So be brave and write your own article about attenuation, and have a good day. Bye-bye.